if you care about coding agents. This story matters for a simple reason. NVIDIA is not just shipping another model name. It is showing more of the data pipeline behind terminal agents, which is usually the hidden part. That matters because the current gap is not only about bigger models, it is about how you create realistic tasks, environments, and step-by-step trajectories at scale. The source frames this as a data bottleneck, and that lines up with what many developers have felt already. Terminal agents can look impressive in demos, but training them for messy command line work is expensive and hard to reproduce. NVIDIA's release is useful because it gives the field a more concrete recipe: task generation, shared environments, and training data design for actual execution. The immediate value is not hype, it is visibility into what changed under the hood. The core release is a systematic data engineering pipeline for terminal agents. The names to remember are Terminal Task Gen and Terminal Corpus, according to the source. NVIDIA starts with existing supervised fine-tuning data for math, code, and software engineering, then converts those static prompts into terminal-based tasks. That includes 163 data math prompts, 35,000 code prompts, and 30 auto software engineering prompts from sources like SWE Bench and SWR Bench. Then it adds a second layer: new executable tasks generated either from seed problems or from combinations of primitive terminal skills. The skill-based part is especially important because it pushes tasks closer to real work. The source says NVIDIA built a taxonomy across 9 domains, including security, data science, and system administration. Then ask the model to combine 3 to 5 primitives into one task. So this is less about chat competence and more about operational competence inside a shell. The most concrete engineering move here may be the simplest one. NVIDIA avoids building a fresh Docker environment for every task. Instead, it keeps 9 shared pre-built-based images with the right libraries already installed for major domains. That matters because infrastructure overhead can quietly kill these systems before model quality even becomes the real issue. The source contrasts this with earlier frameworks that generated 1 Docker file per task, which created long build times and more failures. Pre-built images make the whole pipeline easier to parallelize and cheaper to run. That sounds operational, but it changes what is feasible at training scale. If you can generate and execute more trajectories with fewer broken environments, you can spend budget on diversity and realism instead of setup churn. For terminal agents, that is a meaningful shift because the environment is part of the task, not just a container around it. The headline result is the one most people will repeat: Nemotron-Terminal 30B reaches 27.4% on terminal bench to points RO. Ahead of Q when 3-coder for 180B at 23.9% and also above the cited numbers for Grok 4 and GPT-5 Mini in this benchmark. The 8B model also rises from 2.5% to 13.0%. If those benchmark conditions hold, the signal is pretty clear. Better terminal agent data can be proper amateur scale, but the careful reading is important. This does not mean scale stop mattering. It means data construction is a stronger lever than many people assumed for this specific workload. Terminal bench to points RO focuses on end-to-end workflows like building environments and training models. So the benchmark is closer to operational task performance than pure code completion. The source faithful takeaway is narrow but important for terminal agents. better trajectories and better task design appear to move the frontier faster than just adding more parameters. 3 details from the source are more interesting than the benchmark brag line. First, NVIDIA says keeping unsuccessful trajectories improved performance, with success only filtering doing worse. That suggests error recovery is part of the skill, not contamination. Second, curriculum learning did not help much. This training worked as well or better, which is a useful simplification. Third, longer context was not automatically better. The source says most strong supervision fit inside 768 tokens, and extending context slightly hurt results, likely because longer traces were noisier. Those are practical lessons. I'm going to teach you how to finally think and speech. But there is still noise here. We are reading a report through a secondary article, not the full paper details in this brief. And benchmark wins do not automatically translate into broad real-world reliability. Still, the strongest signal is hard to miss. NVIDIA is arguing that term intelligence improve when you engineer the data pipeline like a product, not like a prompt collection.